Hello and welcome, everyone. My name is Mark Henry. I'm a senior engineer with Opmantic's North American office. And today we're going to be talking about how to improve your network performance by 50% every month. This is a topic that's really kind of very near and dear to my heart. As a systems engineer myself, as someone who has built and operated managed service providers and also set up NOC centers for some large 24/7 service providers over the years, being able to improve the quality of the network ends up making my life easier, because what it does, of course, is it reduces the number of false events that have to be looked into, researched, and fixed day after day after day. So today, for those of you who are live in the GoToWebinar, we will be following up this presentation with an email with a link back to a recording for this. For those of you who are coming in and finding this on Opmantic's YouTube channel or on the opmantic.com website, thank you very much for stopping by. Make sure you pick up a copy of the handout while you're there. For those of you in the webinar, you can get the handout from the GoToWebinar panel. If you check out the handouts pane, there's a PDF file there of this presentation. It has all of the links and all of the content you'll be seeing today. Again, if you're in the live webinar, please submit your questions anytime. We'll be doing Q&A throughout. Please use the GoToWebinar questions panel, and we'll try to respond to those as they come in. We do have a very full house today, so we will do the best we can to answer everyone's questions in the time that we have. If we don't get back to you, feel free to email me directly. My contact information is on the last slide of the webinar. And finally, for those of you here with the GoToWebinar piece, if you leave early or at the end of the webinar, please complete the exit survey. It's just 3 quick, short questions. We use those to help drive future selection for topics. All right, so what are we going to talk about today? We're really going to take a look at 4 big picture concepts. The first is how to use trending data to intelligently adjust fault management. So it's the concept of switching from fixed static thresholds or alarm settings to trended settings. We're going to talk about how to remediate network events to reduce background noise and load. And that's not just load on the engineering team, as in troubleshooting events, but it's also load on the network, right? And we'll give some examples later on today of negative impact on network equipment. We're also going to talk about how to manage device configuration to optimize performance. And we're going to talk about how to identify high bandwidth users and quality bottlenecks. All right. So why? Why is this subject important? Simon Sinek, big advocate of why, ask why. I try to ask that myself as part of critical thinking. Why is this an important subject to us, right? Well, what causes poor network performance, right? There's the list is a mile long. In my experience, it really comes down to 4 things. In many cases, it's poor network design or architecture. Systems are growing, whether it's through M&A or through new application deployment, new equipment deployment, and the overall architecture isn't being looked at and being adjusted as additional load gets added, right? Also, insufficient hardware bandwidth capacity, right? Many people want to combine the first 2 bullets into one, but they're actually very, very separate concepts. You might be purchasing MPLS circuits, you might be buying internet bandwidth, and as your users grow, as their reliance on internet connectivity, connectivity with remote offices, live connectivity to remote data storage sites grows, that can put a real strain on your overall bandwidth. Number 3, poor cable selection or installation results in high error rates and slow data transfers. And whether that's the cabling itself or the cable terminations, the end connectors on the cables, poor cable routing. We ran into a situation not long ago where a client had routed their cables following a 440-volt power line, and they'd purchased cheap unshielded cabling, and those power lines were actually interfering with data transfer and causing a lot of error rates and slow data transfers. And the fourth thing that we often run into, or we often see, is unauthorized user activity, right? And that may be employees, bringing up Netflix and having a movie open over on a side panel while they're doing their work. It might be people on Facebook, on chat, with movies running in the background and Facebook refreshing and eating up bandwidth. Or it could be BitTorrents, right? Peer-to-peer file sharing systems. We even talked to a client just the other day who discovered that their server network was being used to house a World of Warcraft server that was being shared out throughout the world. So all kinds of things are putting, a strain on the network, and these things, of course, cause challenges. And when that happens, devices start popping up, whether it's SNMP information, SNMP traps, whether those are syslogs that are growing to from megabytes to gigabytes and even terabyte sizes that are trying to be consumed and parsed and acted on. So looking at these types of things and understanding what can be done, and then addressing those, quieting those down, and not necessarily turning off the network monitoring solution, but instead quieting down the events at the device and addressing those issues allows the device to focus more on the job it's meant for, rather than on reporting that it's having a tough time doing its job. So to continue the concept of why. So we have these issues happening across our networks, happening with our servers, impacting our applications and our user experience. What does it affect? Where does it go to? What does this speak to? And frankly, when you look at something like Gartner's IT Service Management Maturity Model, normally I try to tie each of Opmantic's applications back to specific line items or bullet points at each of the different levels of the ITSM and identify where each application impacts. But the truth of the matter is that when you're working on improving the overall quality of your network and how well it responds, how well it works, you're really addressing every single level of the IT Service Management Maturity Model and every bullet point. You're touching on each of these pieces somewhat, and you're improving the quality of the services and therefore the value to the organization of the IT department. So what are the pieces of the puzzle today? Opmantic has several products within its portfolio that we offer. It's everything from device discovery and auditing solutions to configuration compliance, performance monitoring, reporting and analysis, even IP fix and NetFlow solutions. Today we're going to be focusing on four parts of that. The first is NMIS, Network Monitoring Information System. That is Opmantic's premier free and open source performance and fault monitoring solution. So it handles all of your performance collection information. We're also going to add on top of that layer, we're going to add in Opie Events, which does operational automation. Opie Events is a kind of a manager of managers. At a very high level, of course, with an operational automation engine behind it, you can actually automate everything from troubleshooting collection to actual remediation and repairing network events that are happening. The third piece we're going to bring in is Opie Trend, which is all about predictive analytics. So Opie Trend takes information from NMIS, from NMIS, processes it, and determines what's normal operating procedure for a device on a specific day of the week at a specific 1 hour window. So every day is broken up into 24 1-hour windows. Each of those windows are compared. So for example, Monday 9 to 10 will be very different from Tuesday 3 to 5. And so Opie Trend looks at every single Monday 9 to 10 window for the past 26 weeks and comes up and understands what is normal operating procedure for every single parameter that's being collected. The fourth piece that we're going to look at today is Opie Config. And Opie Config is all about configuration and compliance management. It's about backing up device configurations, comparing the current backed up configuration against the last one that was stored, and raising events on configuration changes. And so it's a very, very proactive way of approaching and making sure that engineers out in the field or subcontractors aren't misconfiguring devices in the field and then getting eyes on that, getting engineer eyes on that, and even rolling devices back. So we're going to be looking at those four tools today and understanding how they all lead and work together to help improve the performance of your network. So just a quick look at a kind of a two-layer approach or a multi-tiered approach to deploying Opmantic solutions. Many people deploy just one Opmantic server. An NMIS server, an individual NMIS server, properly configured with the right amount of RAM and CPU and fast disk access, can handle anywhere from 3,000 to 5,000 devices. Start adding in the event management, our charting display system, maybe even adding a second layer in, so you have one layer of polling engines and the second layer of master servers above that. And you can really scale out Opmantic solution sets from a handful of devices all the way up to hundreds of thousands of devices. So we have several multinational ISPs and MSPs that are working in the 100, 200,000 device plus category, and who are approaching it in that multi-layered approach using combinations of on-site behind the firewall pollers and web-delivered or cloud-delivered master servers set out geographically. All right, so we've talked about the why. We've talked about why this is important. We talked about the things that cause network problems, network events, errors that you'll see, and we also talked about some of the driving factors for those. So let's actually get into how we're going to identify what's happening, and then how we're going to drill into that, and then how we're going to remediate that information. So the process is very, very straightforward, and it's important to understand that you can apply this process, at least steps 1 and 2, even if you're only using Opmantic's NMIS platform. So we often have clients who come to us and say, I don't have much of a budget, we're a small shop, I can't afford anything at all. We really like your NMIS network monitoring solution, we want to go with that, but how do I use that and how do I leverage that? So steps 1 and 2 of this 4-step process can absolutely be done with NMIS. You will not get to that 50% improvement every month, but you'll get close. You might get 35, 38% of the way there with the information that you'll find in NMIS. To get yourself all the way to that 50%, you really have to add in, again, Opie Events, Opie Trend, and Opie Config. And we'll see why as we step through some of these examples that we've got here today. So step number 1 in this process, and just to kind of give you from an implementation standpoint concept here, to do these steps, what we often recommend, and this is for any team, right? Whether it's a team that has a dedicated NOC, or whether it's a team that's just 2, 3, 4 guys sitting around in cubicles all day answering help desk tickets. The concept is to split off a percentage of your team. That might even just be one person for 2 hours a day, or one person for 2 hours every 3 days, right? But split off part of your team. We really recommend, if you have a large team, that you start with a team with at least one mid or senior level engineer and 1 or 2 junior level people who can actually do a lot of the footwork and data analysis and pull information for that senior person to really act on. But the concept is to have a team that can dedicate some time every single day to working this process. And if you do this for the entire month, right? If you do this every single working day for the entire month, we've really seen improvements of 50% from our customers. We've actually seen some customers who have achieved much higher than 50% improvement very, very quickly in just the first 10, 15, 20 days because of the way that in many effects, events that are stacking up from devices can really impact their performance. So step number 1 is to remediate the top 2 to 3 devices with performance issues out of acceptable norms. So starting with a list every single day of devices that are generating events, and hit the top 2 or 3 devices every single day. Identify what the events are, work through that list of events, address those lists of events, right? So that the next day you're not addressing the same things again. You're working on a whole new list of devices or a whole new list of events. Step number 2 is to remediate the top 2 to 3 events every day. So you might have a list of devices. In fact, when we walk through this, we'll talk to you about how Opmantic solutions break down the differences between problems with devices and the numbers of events. So you might have, for example, a firewall that's generating a rather low priority event, but it's doing it 10,000 times a day. And because it's doing that, that's affecting that device negatively, right? So that's a very noisy device that's not really of a very high priority. So that would be step number 2, right? Remediating something that's a very high numbered event. But then you might have a router which is relatively silent, but it's running very, very low on memory, very, very high on CPU usage, and it might have high errors and discards, right? So identifying what things are important through those 2 pieces. And again, you can do steps 1 and 2 with NMIS alone, although if you have licensed Opie Events, we prefer you use Opie Events because the reporting in Opie Events is much more targeted than NMIS and will really help get you to that 50% point much, much faster. Step number 3 is to enable Opie Trend. So the concept is to start gathering data with Opie Trend over time, and once you've gotten to anywhere between 30 and 60 days of data captured, enabling events from Opie Trend to be processed by Opie Events, and then start working through those lists of events as well and understanding the difference between trended events and thresholded events. And then step 4 is to check device configuration collection. So it's getting OP config up and running, it's collecting device configurations, it's monitoring those, and then alerting on device configuration changes that are important to you and your team. 4 simple steps, do it every single day, assign some dedicated resources to it, and I'm guaranteeing you that you will see a 50% improvement in your network performance in just the first 30 days of implementing our solutions. We have a question here. So Peter asks. So Peter says that he has different solutions in place. He doesn't have Opmantic solutions in place. He's asking if these processes can actually apply to his tools as well. Not being familiar with the tools that you have here, Peter, I can't tell you if the types of reports that we're going to show you today are available there. Many solutions have them. So yes, you can absolutely apply these same types of processes and steps to solutions other than Opmantic's network monitoring solutions. So yeah, you can absolutely apply these things to the solutions that you have today. Although I think if you follow along in today's presentation, you'll see some advantages that Opmantic solution has over yours. So moving on and drilling in a bit. So let's take a look here at NMIS. So what I'm going to do now is I'm going to switch over to our demo server. So this is NMIS, Opmantic's Network Monitoring Information Solution. Again, this is free and open source. If you are adding in other Opmantic solutions, so if you're adding in Opie Events, Opie Config, in fact, you can see those in the browsers tab at the top of the screen. Those all sit on top of NMIS. So NMIS's database acts as the core and kind of the administrative polling engine for pulling performance data from devices, and then the other Opmantic solutions sit on top of that. I'm going to close a couple of windows here just so we can clear out the screen. And then what we're going to do is we're going to take a look at reports. So reports, current, top 10. Now, for those of you who are following along, again, you can download a copy of the PowerPoint presentation, which gives you a complete list on slide number 12 of each of the steps and each of the windows that I'm looking at, and they reference back to the menu in NMIS. So again, proactive remediation really starts with the concept of saying, I want to take the top 2 to 3 offending devices and the top 2 to 3 offending events every single day, and I want to address those things. Just start with the top 2 or 3. If you only have enough time to deal with the top 1 or 2, that's fine. Just deal with those, right? If you can only deal with 1 a day, if you're short on resources, maybe it's just you and you're managing a large business and maybe it's multi-sited and you've just got NMIS up and running and you're getting your arms around the network, then just address the top number 1 item, right? And you want to look for things here like response time. How long does it take for that device to respond to a poll from NMIS. So here you can see the B&E Lab P1 is taking 213 seconds. In fact, if you take a look at the top ones here, all of these are all problematic. These are all far too long. They shouldn't be taking this much time. So some things that you want to consider when you're looking at polling time, just consider the speed of light, right? What's the latency between where you have your poller, where you have NMIS in this example, and that device? If it's a great physical distance, that could be an issue, right? You might want to deploy a polling server closer geographically to those devices. If there are a lot of hops, right? So if you do a trace route between the polling server and that device, if you've got a lot of hops, if you have more than, let's say, 8 or 10, then you're probably looking at a good deal of latency. So you might want to look logically at trying to get that polling server closer to that device as well. Or you might simply have a device that is really, really overloaded. So I happen to know, for example, that this little switch, this little Cisco switch, this meatball here, that guy's actually around the corner. It's logically, it's about 3 hops from the polling server. It should not be taking 200 seconds plus to respond. So if I wanted to start working on this, I'd actually look and say, okay, what can I do with these top 3 issues? The devices at the B&E lab, those ones happen to be in South Korea, and my polling engine is in the cloud, but it's located in Australia. So I'd look at the latency between that location and my South Korean office and determine if maybe I need to deploy a polling server there in South Korea. I'd also want to look at Meatball and try to figure out, why is it taking so long? Why is it overloaded? Is it running high on CPU, low on memory? Is it maybe stuffed in a corner somewhere and it's overheating? Does it just simply need a patch and a reboot? Working through this list, you want to look at things like, here we go, we have average ping loss. So this device, test 001, has 100% ping loss. That device isn't responding at all. Looking further down, now we've got CPU load. So we'd want to look at these devices. Now, we happen to know that these types of devices, these Cisco routers, these ones all happen to be software-defined devices. It's actually normal for them to run at 28, 29, 30% CPU load all the time, even when they have very little load running through them. So because of the type of device they are, I can actually discount those. But what I'd want to do is, I learned that by researching the type of device, the manufacturer, the model, how the device is configured, how it's deployed, where it's used, and how it's operated. Same thing with memory. These devices, this class of device, same devices that we're seeing kind of 30% on CPU, we're also seeing 65, 66% down here on processor memory. So if I discard those pieces, I would want to start perhaps looking at these guys. Why are these guys running at 48, 49%? Is there enough load over there to substantiate that high processor memory used? Same thing on the next list, I/O memory used for routers. Looking through that list and really focusing in on these ones here that are at the 67% standpoint. Is that normal for that manufacturer model implementation? How much traffic is running through it? How much load on it? How is the device configured? Right? Is it running some kind of QoS? Is it running some kind of NetFlow or IPFix collection that might be also adding to that I/O memory used? Now, not every pointer here is a problem, right? But it's understanding and using the information that's here to help drive those types of those inquiries and questions. So we're looking at devices now. Now we're down into interface traffic. Interfaces by percent utilization and interfaces by traffic type, and then determining if that's enough or not. Now, this is a small demo network. There's very, very little traffic running through here, but you'd want to be looking at interfaces that are running definitely north of 80%, but really I like to look at anything running averaging north of 60% utilization. So what else do we have here? Network performance. Network performance, top 10. Now this is a slightly different list than the one that we just looked at. So we're still getting response time, CPU load, still getting percent utilization. Now where the reports current focused in on routers, this is all devices. So you'll also see that we have interfaces on switches, on servers, etc. Same type of information, take the same direction. Next, we want to look at the events that are happening across the system. So service desk, alerts, events. And this breaks down all the current unacknowledged events throughout the system. So just like we talked about, you would focus on the top 2 or 3 devices each day. Here you want to really focus on the top 2 or 3 events every day. And you want to understand what's causing the event, where it's coming from, and you'd want to prioritize these. Now you can prioritize these by priority. So I would look at all the fatal events, so all the red ones. So you've got Asgard, you've got the B&E router, B&E Lab P2, some fatal pieces here, Charlotte router here, proactive interface, discards output packets, EMEA router. So I'd want to organize these perhaps by all the ones that are marked as fatals and work just through those pieces. Another piece for you, reports, current, collect update time. Now, depending on how many devices you have in your system, this could take several seconds for the system to come back. Once you have this up, I sort these columns by collect time to start out with. Now, the earlier report, the report's current top 10, does give you collect time as well. But remember, this one is what is the collect time from the window. So I have the last 24 hours. So this will give me collect time averages over the last 24 hours. And again, I don't want to look at anything that was really north of 20 or 25 seconds. Really large switches or routers, certainly with the number of interfaces they have on it, if you're collecting on more interfaces, it can take more time to collect on all those. You do want to make sure that your collect time always stays less than your polling intervals. So if you're polling every 5 minutes or every 300 seconds, you absolutely don't want anything with a collect time that exceeds 300 seconds. Because once you exceed 300 seconds and the next polling interval starts, it'll actually cancel the first collection cycle. You also want to sort on update time. And let me reverse sort that now. There we go. So I want to look at update time. So update time is pulling detailed information from each device once every 24 hours. This is primarily information that doesn't change. So collections gather information that change often, like interface statistics, whereas update time might pull things like a device name or description, fields that don't generally change often, and so it happens once a day by default, and you can, of course, override that, do that more often or less often if you feel the need to. And again, I'd want to make sure that my update times are reasonable. Generally speaking, I'd want something in the 45-second range or less. The ones that are longer are generally much larger devices, or they're further away, so there's a bit more latency in gathering the information. And again, the whole point in this is I'm using this information to drive my day-to-day operations, right? So I've got some kind of a troubleshooting team, a Tiger team, working every single day, maybe just for a couple of hours on this list of the top 2 or 3 devices and the top 2 or 3 events that are happening across the system. One last piece I want to show you before we move on. System configuration check, node admin summary. And then in the top left, I want to click only exceptions. So this is going to give me a list of devices that have problems. Something's not working. Maybe it's not being collected on for some reason. Maybe SNMP isn't working, WMI isn't working, the credential set doesn't work. Maybe we don't have the right model assigned to it. Something is not collecting correctly. and we want to figure out why, and we want to fix that. All right. So that's our approach if we only have NMIS. Now let's say that you've also licensed Opie Events and you're using our event management system. So our event management system is running, it's going along great. It's processing events, whether those are local events, whether those are synthetic events. Like, for example, we're actually pulling in Twitter feeds from the National Weather Service, and we're generating events from that. So let's take a quick look at what a Twitter feed event looks like. So a warehouse storing cars collapsed due to snow on the roof. Yay. Lots of good value in there as well. I'm not quite sure that needed to be a priority for, but those types of things can be managed throughout Opie Events. Other types of events you might see, for example, we've got a service degraded in, we've got a check disk write. So we're actually reading and writing data to a disk to test disk write speed. And in response to this, we've run a couple of scripts. One script is having problems, so you can see that there's one down here that has some invalid options. But we are pulling back looks like a df-h on that drive, and we're gathering some information and we're storing it. So what Opie Events also gives us is what's called a daily summary report. So back to that concept of giving your teams the information they need. So where NMIS has you bouncing around and going in several different places, you can actually configure a daily report. And I like to get this interactive live on the screen rather than as a spreadsheet or as a interactive HTML file. And the reason for that is because I can actually interact with this. So as I click on these devices, I can actually drill into these events. I can find out what's happening on these events, and I can really understand what's driving these pieces, right? Now, there's a lot of great information that is here. What I really want to do is I want to kind of take a look for this. So I want to see events by event count. Top nodes and events by event count. And what this does for me really is this gives me a count on how many events are happening that are coming from each different device. Now here you'll notice that there are several events occurring. These ones are configuration changes, and these are actually normal. We actually have a couple of devices set up on our demo network where a device creates a lot of errors and discards in an interface, and then we actually pick that up as an event, and then we issue a configuration change to that device. So those two, again, I'm evaluating these events, and I'm saying, okay, these two are understood. They're normal operating procedure for this system. But then I would start asking myself, what about the next two events? Is that expected? Now, obviously, this is a closing event, but this is opening event. What about this one? What about this opening event? What about this one? So I'd want to take the top, again, 2 or 3 of these events, because these are the ones that are the noisiest in the system. These are the ones over the last 24 hours are creating really the most noise in my system, and address those. I also want to look down just below this, the event counts by node and name, and look at the top 10 nodes by event weight. So the event manager, Opie Events, actually gives kind of a weighted analysis to the importance of each individual event. So for example, the events on OR, even though there are fewer of them, they have a higher weight than perhaps the events out here on the Toro server, which only had 8 events that has a much smaller weight. So these weighted events, and there are rules to how they're weighted. They're all set up in the configuration file. You can actually adjust your event weighting, although frankly, we don't recommend you do that. The system's actually been lined out based on input from device manufacturers, as well as more than 10 years of input from working engineers out in the field working. And so those calculations are really well defined at this point. But again, what this does for you is it helps you identify again, the top 2 or 3 devices and the top 2 or 3 events every single day. But if you focus your efforts every day on addressing these types of issues that are popping up, and if you can just address 1 or 2 of those every day, identify what's causing it, is it something that's important that needs to be dealt with, what's causing the problem on the device, right? In many cases, what you'll find, especially over the first week or so, is that many of the noisiest devices, the ones that are producing the most events, are producing events that don't need to be processed, that are not something that a human needs to look at, and that frankly don't need to be processed by the network monitoring system or by the event handler. And so in many cases, you can actually go to the device and reconfigure the device not to generate the event to begin with. Now, we often see our clients where they've actually silenced the network monitoring solution. So they've either raised their thresholds or they've simply turned off certain events. The challenge with that is that if the device is still generating the event, is still processing and creating that event and then sending it, you've created 2 problems. The first is the device itself is really, really busy creating an event that no one's going to do anything with. The second piece is that every time it sends out an SNMP trap, every time that it adds a line to a syslog and then pushes that syslog out to be processed, every time your network monitoring solution pulls that device using WMI or SNMP, that's eating up bandwidth that doesn't need to be used. And so we often see that a lot of the traffic across the network is actually SNMP, right? So it's ICMP and ping response, it's SNMP traffic, whether that's SNMP polling or SNMP traps. It's syslogs being moved from devices to your syslog management. And just on a side note, Opie Events does parse syslogs. You can use it as your syslog processor. It'll parse syslogs, it'll deduplicate, it'll correlate events from syslogs with SNMP and WMI events coming from NMIS. But silencing those alarms at the device so the device isn't creating them to begin with, you'll oftentimes see massive improvements in CPU and memory availability on those devices when they're not generating the events that no one's going to do anything with. And that's really an important concept for you to, each of you, to really understand and absorb. Okay. So I'm going to back up here for just a moment. We're going to take a look at events and Opie Events. I'm also going to bring up the event monitor here. So this is the network metrics and health screen in NMIS. And what this does is this lists all the groups that devices are placed in. And then across the top of the screen, you have a health graphic. So throughout each of these, you can break down and you can drill into these pieces, and you can see the overall health of the individual devices. Now, each of the events that are actually coming through the system, so if we look at current events and also network events, so network events gives me a list of all the alarms that have gone off, right? So these ones in green, these are up settings, and then you have, for example, service degraded, write check bad, 179 megabytes, outage, current true, service down fatal, 92 megabytes writing. So you'll see these different values that are in here. These are primarily, these are all thresholded values. These are static thresholds or static alarms that are defined within NMIS for every single type of event that any device might be able to generate. Opie Events is much the same way. We're processing those events coming from NMIS. So for example, you can see that service degraded piece for the eject disk write. You can see proactive interface error input packets, and let's just take a quick look at that. You can see here that it has a kind of, again, a static threshold, so a static alarm level of 0.5, and you can see that it went off at 19.7. So a poll, NMIS did a poll, a performance poll on that device. It pulled back its metrics, and for whatever reason, interface error input packets had jumped to 19.7 since the last performance poll. And this kicked off a whole series of performance changes. Traffic was actually rerouted off of this interface onto other devices because of that event. But again, that's a thresholded or a kind of a static alarm. Beyond static alarms are OP Trend, the concept that you can actually track information. And we're taking a look here. This is CPU load, but let's take a look at input utilization. And we can drill into a specific device and see what it looks like. And if we just take a look at the last 24 hours. So you can see, for example, the blue upper and lower control lines. So this is a standard deviation. So for anyone who's done statistics, there are actually 3 standard deviations. So the green line is the mean, or what's average, what's normal for this hour, these 1 hour windows during this time period. You can see that there are small spikes that are happening, but because they're within the upper and lower control arms, that's perfectly acceptable. If we go back to Opie Events, we're going to take a look. You can see that we have some Opie Trend interface issues here. I'm going to take a look at one of these. So we're going to take a look at mid-guards. All right. So here, if in utilization exceeded positive control by 14.6, and then there's a link to Opie Trend. I'm just going to grab that link. We're going to go back to Opie Trend. And I'm going to load that link. Apologize, I missed a slash. There we go. And so you can see, for example, the upper and lower control arms here have a very small window, and then there's a very large deviation. And if we plot out where the deviations occur, and we can add in what's called the EV data set as well. Now when I zoom into this, you can see how many points are deviating in the red lines, and you can see the purple area is the area where all of the statistics for that time period are well outside the acceptable window. So what this is doing for us in this example is just looking at this one interface and determining what is normal procedure for if-in utilization on this one interface. And it will do this for every single interface you have. It'll do it for your device's memory. It'll do it for your device's CPU. If you want to do it for temperature as well, you can. We have several clients who, because of the way their buildings are configured, they have switch closets with routers and switches in them, which are not air conditioned and which don't have good airflow. And so the devices in those enclosed spaces often run very, very hot. And that's normal for them, and they accept that. And so they didn't want alarms on those devices, but the devices that are in their data center, which is air conditioned and cooled and managed and maintained, they didn't want to change the temperature settings on devices. They just wanted the system to understand what was normal operating procedure for that device on a certain hour a day, day of the week, and accept it. And so what they did over time is they implemented Opie Trend. And once there was enough information in Opie Trend, about a month and a half worth of information is good to start, they actually turned off working with any of NMIS's pre-built, predefined static thresholds and let Opie Trend drive all the alarms for the system completely. It's important to understand that when you're implementing Opie Trend, you do need to have anywhere from 45 to 60 days before you enable trending. The more data you have, the more accurate your trending will become. So if you enable it at day 30 and you're dealing with a lot of alarms, those will quiet down as the system understands what, again, is normal operating procedure for devices. So it actually learns from itself. It learns from the behavior of the devices. And then you can use this information in Opie Events to really drive how Opie Events responds to events. And so you can differentiate between thresholded alarms and trended alarms, and then you can actually set up proactive troubleshooting, so you can run scripts, gather information, store that information. You can even go so far as to take proactive action. For example, in the event we looked at a moment ago, where the system actually rerouted traffic off of a device and onto another one. The last piece today that we're going to cover in today's session is talking about OP config and configuration compliance management. The concept that you can collect settings for a device. So for example, looking at show startup config. And I like to look at these side by side. And if we go side by side and we look through, you'll see that we have a change here. So I have a command on the left-hand side. It's highlighted in red. There's a line through it. So that was there in the previous edition of this command, and it's not there now. So there's been a change. Someone has changed the configuration. Now, I happen to know that this was actually done programmatically. It was actually in response to that errors and discards event that we had a moment ago. This is actually the rerouting of traffic on and off this interface that's being done proactively by Opie Events and Opie config. However, I can capture this information, and now I can take action on this. So we can raise an event, we can run troubleshooting scripts, we can notify people, we can create help desk tickets, we can even go so far as to roll the device back to a known good configuration. So for example, we have a telecom company in the Pacific Northwest. One of the things they do is they create a gold image for every single device, and they store it. And if at any time the configuration for that device is changed from the gold image, they simply push the gold image back to the device at the same time as they're raising a notification to their engineering team. So the engineer gets notified, hey, someone changed a parameter on this device. Here's the information from when we pulled the setting, here's the errant setting, and oh, by the way, we pushed the correct configuration back down to the device. So they get that information as well. So OP config gives you not only the possibility of raising events on configuration changes, it gives you configuration backup as well. It gives you the ability to push configurations out to devices, and you can also do compliance work with it as well. So if you're bound by things like PCI DSS, HIPAA High-Tech, you can actually create your own compliance rules and then apply those and make sure that all of your devices are in compliance. So why am I bringing this up? Why does this sound like a sales seminar? Because it's really not. But at the end of the day, what you want to use OP config for is to raise your game up, right? So it's not just chasing down events or chasing down problematic devices with high CPU, low memory, high temperatures. It's actually being proactive with things like OP Trend and understanding what's normal on a device, but also configuring to gather device settings. So if someone changes a configuration setting on a device, you can actually respond to that before it really becomes user impacting. And that's important because there are a lot of studies that are out there that say anywhere from 40 to 60% of network downtime is actually caused by human error. It's misconfiguration of a device, right? So something wasn't put together right, a change wasn't made properly, a semicolon was missed from the end of a command line, and everything's broken. So capturing that earlier, the faster you can capture that information, that state change, and then start drilling into it and understanding what happened, the faster that you can actually remediate the problem and reduce the impact. Switching back over to PowerPoint now, I'm going to move forward through several slides. So these are all the ones that I've been working off of the last few minutes as we've been showing you the different products, NMIS, Opie Events, Opie Trend. Again, if you're on this live, you can download this presentation in the handouts pane. If you've come to the Opmantic YouTube channel, please find all this information on the opmantic.com website under Learn. So you can get this all this there. The last piece to this, and I'm actually going to leave this for you to kind of think on as you take away from this presentation today. So after you've adopted all of this, after you've been applying these 4 steps over the past 30, 60, 90 days, and you've seen good performance, right? So you're still dedicated, you still have that Tiger team in, they're still working the problem. The next thing you want to do is you want to start looking at traffic reports, device performance, WAN and LAN reports from your reporting system. You want to start adding in Opie Flow or some kind of NetFlow or an IPFix analyzer. You want to identify what the top talkers are, what the noisy applications are on your network, and who's using that bandwidth, on what, and why. Next, you want to apply some kind of Cisco IPSLA mesh, right? There are several other ways to do something like an IPSLA solution if you don't have Cisco devices. If you do have Cisco, you should absolutely be generating some kind of IPSLA mesh. We have a great tool here called OPSLA that lets you deploy polars and get those up and running in collectors and really create a nice mesh traffic and understand what's happening for connectivity between devices. And finally, of course, you want to be doing some kind of traffic shaping with CVQoS or Juniper QoS. So give those pieces some thought. Wish you luck. If you have any questions at all, please reach out to me. That is my cell phone number. That's my direct email address as well. I'm happy to answer any questions you have. If you're interested in a demonstration or doing a proof of concept of any of our solutions, feel free to reach out to Tom Weary at usa@opmantic.com. And if you're outside of the North American region, just reach out to Tom. We'll do an introduction to your local regional account manager and get you guys moving with a demonstration and a proof of concept. Thank you all very much for your time today, and look forward to seeing you again at a future presentation.